Perhaps the two best candidates for finding non-Earth life in the solar system are Enceladus and Europa, both of which have mounting evidence for not only having liquid water oceans locked under shells of ice, but also the right chemistry for life to arise in those oceans, along with a growing possibility of the presence of geothermal vents. In Europa's case specifically, life has had plenty of time to evolve there, and there have been tantalizing clues over the years that something may well be going on. See my video on the possible Europa life detection on this channel, link in the description below. The trick in finding out for sure, though, is getting through that ice and having a look at the water. One way of doing that, of course, are probes that melt or drill their way through it. Those take funding and time, and well, when dealing with Europa particularly, one can get impatient while waiting. But in a new paper by Philip Judge, he proposes a method for looking for life at Europa and Enceladus from the comfort of home here on Earth. He suggests starting with lab experiments here on Earth to try to recreate an interesting feature that is present on both worlds. While the oceans are locked under ice, the ice does crack, and plumes of water eject out into space from the ocean below. As a result, spectroscopy and polarimetry could be applied to determine if we can pick up biomarkers from water taken from our own oceans. If it turns out we can, and once we know what to look for, it might be possible to use some of the very large telescopes both in existence now and those coming online over the next few years, or the James Webb Space Telescope, to see if we can detect biomarkers in the plumes of Enceladus or Europa. You would do this while the moons transit across the face of Jupiter and Saturn. This is easy for Europa, which transits in front of Jupiter regularly, but Enceladus won't start transiting Saturn again until 2022. Data taken this way would be noisy, but if you knew what you were looking for, it does seem viable. Europa's plumes are less active than those of Enceladus, so you'd have to catch that moon in the act. And with Enceladus, the author notes that there is another way to study material from that moon. It supplies Saturn's E-ring with materials, so the ring itself could also be studied. The James Webb Space Telescope will be of particular use here, but I must admit that I really like this idea. Europa is a captivating moon with its ice, oceans, and potential for life. My video on the detection at Europa covered a tantalizing clue, but ultimately it was inconclusive. It's nice to know that we may be able to answer the question using our equipment here on Earth relatively quickly without having to rely on the time frames of exploratory probes. Thanks for listening. I am futurist and science fiction author John Michael Gaudier, who once wrote a book called The Salvagers, one setting of which was a colony on Europa where the native aquatic life was found to be quite tasty by the colonists, especially fried. And on that note, be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.